Hey everybody, welcome back to another CodeSpector video. I thought this week I would take a break from the data structures and do something a little different, and start a new Intro to TypeScript series for 2023. My goal with this series is to help get a basic understanding of TypeScript, what it is, how to use it, and the main features of the language. Let's start with a little background on what TypeScript is. To understand what TypeScript is, let's first talk a little bit about JavaScript. JavaScript was a programming language developed in the 90s, specifically with the internet in mind. In the past 2 decades, it has grown into one of the 3 components used to program for the web: HTML, CSS, and JavaScript. HTML and CSS aren't programming languages, but they're used to style and structure the layout of a website. JavaScript, however, is an actual programming language. JavaScript has gone through many iterations over its 2-decade life, growing and adding new features. An entire ecosystem of frameworks, tools, and packages have grown out of JavaScript, such as Node.js, React, Vue, and, of course, TypeScript. The reason TypeScript has become so popular in recent years is directly based on how popular JavaScript became as internet programming grew more prevalent. JavaScript had some fundamental flaws built into the language that the TypeScript developers hoped to fix. The main benefit of TypeScript is that it turns JavaScript into a full-fledged, typed, object-oriented programming language. TypeScript is a compiled language, or I should say transpiled language, because it compiles into JavaScript. One of the main benefits of TypeScript is that we can surface errors before the app is in production. Since TypeScript is transpiled into JavaScript, we can find errors during the compilation process and prevent nasty bugs from ever making their way into our production code. Another benefit of TypeScript is that it enforces static typing. This means that we can't take a variable that's a number and magically turn it into a string. JavaScript has no problem with this, but TypeScript will not let us do it. This may sound simple, but it can actually save you major headaches in the long run. The nice part about TypeScript too is that it essentially is JavaScript, just with some extra features baked on. Any valid JavaScript code is also valid TypeScript. We can also use JavaScript libraries with TypeScript. Today we're going to be running some TypeScript code straight from the command line. To do this, we're going to need a package called tsnode. Tsnode allows us to run our TypeScript files straight from our command line without needing to compile anything. I'll include a link in the description for how to get tsnode installed and running on your machine. It's time to write what every self-respecting programmer writes as their first program. Hello world. I have this file, hello.ts, and I have it open in my editor, which I'm using Visual Studio Code. TypeScript uses the same output as JavaScript, and that's console.log. When you use console.log on a website, it will display text in the dev console in the browser. But when we use it with a command line script, we will get text output to the command line, similar to cout or printf if you're familiar with C or C++. So let's write our console.log. Hello world. To make sure tsnode is set up properly, let's run this. npx tsnode hello.ts. Hello world. And just like that. Pretty simple. Now that our script is running, let's talk about data types and variables. TypeScript has 3 primitive data types, similar to other programming languages. There are strings, there are numbers, and then there are booleans. TypeScript numbers are for any type of number, floating point, or integer. The same thing goes with strings, but for strings and characters. Boolean variables, similar to other programming languages, can be both true or false. Let's add a variable to our hello world output. Alright, so I'm going to create a new variable called channel name and assign it to the value of CodeSpector. So based on this line alone, the TypeScript has enough information to know that channel name is a string. That's because we're directly assigning it to a string right away. Sometimes that won't always be the case though. So let's take another example. Let's say that we don't want to assign channel name to a string until later on. To let TypeScript know that it's a string, we'll use this. This is called a type annotation. Basically, this is telling TypeScript channel name is always going to be a string. Now, if we come down here and assign it, if we try to assign it to something else, TypeScript's going to get mad at us because it's a string and we can't assign it a number. So let's go back and have it assigned to CodeSpector. And now let's change our console.log to include this variable. So there's a couple ways that we can do this. The first way is like this. This is called string concatenation. Since this is a string and our variable channel name is a string, essentially we can just combine them by using a plus operation. This tells TypeScript, hey, turn these two things into one thing. So let's run that and see what happens. And just like that, we have our new string, hello CodeSpector. There's another way that we can do this, and that is called string interpolation. This lets us embed variables directly in our output like this. So I'm going to delete this whole thing, and instead I'm going to use backticks. Let's write our hello, and then instead of adding these together, I'm going to use a $sign and then curly braces. And now I can embed variables directly in our string like this. This is a good way to compose complicated strings out of many different variables. A good example of this is an email marketing campaign. If you need to send a ton of emails based on dynamic information like a person's address, their name, their interests, you can basically compose a template and then input the information directly like this. It's a very useful tool. For numbers and booleans, we declare them exactly the same way. So let's create a variable called age and set it equal to a number and assign that number 45. Let's do the same for a variable called truth value. It's a boolean and we'll say it's true. In TypeScript, we can declare variables in 3 different ways. There's this let keyword, then there's also var, and then there is const. So const is different than the other two because const means constant. And essentially what that means is once we set that value, we can no longer modify it. So let's look at an example. Let's set age as a const, and then let's come down here and try to set age and add 1 to it. Now, if you can see, we're getting this red error line, and it says we cannot assign to age because it's a constant. This means that it is stuck at the value 45, and if we want to change it, we need to create a new variable and put that information in it. So each primitive, strings, numbers, and booleans, have their own possible operations or even functions that you can use with them. So let's take our string, for example, channel name. So let's get rid of this, and let's say hello channel name, and then we're going to put a period after that, and then go to uppercase. Now, as you can expect, this is going to convert all the characters in our CodeSpector variable to uppercase. So let's run that and see. Just as we thought. We can also find out how many characters are in a string by using .length. So let's create a new console.log and say channel name is of length, and then what we'll do is we'll use that same concatenation that we used before and then go channel name dot length. And now you saw how my single quotes got turned into double quotes there. That's because I'm using an add-on called Prettier, which basically automatically formats my code for me so that any kind of silly mistakes that I make will get picked up by Prettier and it'll format it properly. It's just one less thing to think about. All right, so let's take a look at this. So CodeSpector has a length of 11. With numbers, we can do any standard arithmetic operations. So let's create a few new variables. We're going to create one A that is assigned to 3. Let's create B, which is assigned to 5. And then let's set C equal to A plus B. And then let's add another variable called D and set it equal to B minus A times 3.6. Now let's console log C and let's console log D. So with these type of operations, it's the same as algebraic order of operations. It'll run the same way that you learned in algebra class in high school. All right, so let's run this. So we have C is equal to 8 and D is equal to 7.2. Now let's make another one called E and set it equal to A++. Now, this plus plus here, that's called an increment operator. All that this does is take A and assign it +1. So A will now be 4. Let's take a look. Oops, like that. Yep, A is now assigned to 4. We can also have arrays of values in TypeScript. An array is just a list of values. So let's make an array of numbers. I'm going to call our array numArray and set it equal to numbers. So when you want to type annotate an array, all you have to do is add these square brackets at the end of the list. So this would be the same if you wanted to make a list of strings or if you wanted to make a list of true or false values. So we're going to set this as a list of numbers, and we're going to set it to 1, 3, 4, 5. Let's also make a string array and set it equal to a list of strings. We're going to have AAA, BBB, and CCC. Now, say you want to access just one of these. Let's come down here and try to look at the very first element of string array, which is AAA. So to do that, what we do is we use the square brackets, and then what we include is what is called the index. So to get the very first value, we want the index of 0. And this is worth keeping in mind. So the very first element of an array in almost every programming language is 0. That is called zero-based indexing, and it's worth keeping in mind that if you have an array of length 5 and you want to access the last element, that last element will always be 4. So let's try this. So let's clear out our previous output and run this. And now we got the very first value of string array, which is AAA. TypeScript also has something called objects, which are basically similar to dictionaries in Python if you've ever written any Python. If you're unfamiliar with Python, TypeScript objects are basically just a series of named keys with values. So let's take a look at an example. I'm going to create a person, const person, and we're going to use curly braces now. Now, we're going to give him a list of properties, is what they're called when it's a variable attached to an object. So there's a property name. We're going to say this person's name is Joe. We're going to give them an age, and let's say it's 35. And so we can see that name is a string, age is a number, and then when we hover over person, we can see that it's keeping track of this. Basically, think of it as a complex type. Now, let's create a new property called favorite sport. We're going to say Joe's favorite sport is football. And we're going to say that Joe's favorite color is red. Now, if we want to access specific things about Joe, we can do that like this. Let's console log. And let's say, use our string interpolation method that we learned earlier and say person dot name. So this dot is how we access things inside of an object. So person.name is person.age, years old. Now if we run this, we can see Joe is 35 years old. There's also another way to do this, which is to access them similar to the way that we access arrays. But instead of having a number, we're using the key name. So let's say instead of person.name, we go like this, we use our square bracket, and we say person name. So this actually functions identically to the dot. It's just that it's a different preference in terms of style. So let's run that again, and we'll see that we get the exact same thing. You can also have objects that have objects nested within those objects. So right now, we have these fields, favorite sport, favorite color. Well, it might be better to just have a favorite field. And then we can have sport, football, and color red inside of this. So basically, we're going to access these in the exact same way that we accessed them before, except we're just going to keep chaining the dots together. So let's say person.name has the favorite sport here we go, person dot favorite dot sport. And let's run that. So Joe has the favorite sport football. And this could keep going pretty much infinitely. There are sometimes really complex nested objects. There are times when we only need a list of keys in an object or only a list of values. Luckily, we have some pretty simple built-in functions for this. So I'm going to create a new variable called personKeys, and we're going to assign it to object.keysPerson. And what this is going to do is return a list of all the keys that are in person. So let's output to the console person keys. And we'll see that we get name, age, and favorite. So you can see here that this only included the top level keys. It didn't include the keys that are subkeys of the top level, like sport and color. We can also do this exact same thing for values. So instead of object.keys, let's say we want object.values person and run this again. And we'll see we get Joe, 35, and then we get an object which contains sport and color. So we can also have arrays of objects just like any other type. So let's get rid of this. I'm going to create a new array called people. And people is going to be an array of persons like Joe. So let's take Joe and let's copy this and put him into the array people. And let's add one new person whose name is Ollie, who has an age of 41 and who has a favorite color of blue. Now, if you see the above example, you can see that there's a difference between these two people. Ollie doesn't have a favorite sport. So what would happen if we went through this array and tried to find out each person's favorite sport? When we got to Ollie, we would end up getting an undefined, which would cause wacky behavior depending on the program that we're writing. So right now, this might seem like an easy thing to spot, but imagine we have 500 of these people, all being returned from a database. How would we know that only one of them doesn't have a favorite sport? So what we can do is define an interface. An interface will enforce an object to be a certain way so that we know ahead of time if something is wrong. So what I'm going to do is I'm going to come here, I'm going to create a new interface called person. And we're going to say that each person should have a name that is a string, have an age that's a number, and then have a favorite object that includes color, which is a string, and sport, which is a string. Now what we're going to do is we're going to come down to our people array and say that people should be an array of type person. So we see right away that we're getting an error in favorite because Ollie doesn't have a favorite sport. This lets us know before our program goes out that something's wrong here and maybe we should take a look at it. So let's add a favorite sport to Ollie and say his favorite sport is soccer. Right away, our error goes away and now we have no problem. Now there may be situations where we don't always want to have to include a certain property in an object. Let's say that it's not a big deal that Ollie doesn't have a favorite sport and that there might be other people who don't have favorite sports either. What we can do is come back up to this interface right here and include a question mark. What this means is that if we look over the type, it says sport can either equal string or undefined. Basically, what we're saying is that sport is an optional field, and whether or not it's there doesn't matter. So let's come down to Ollie, remove sport, and we'll see we're no longer getting an error. That's because sport is no longer a required field. However, if we were to remove age, we would get an error because age is still a required field. Now let's talk about conditionals. TypeScript conditional structures work identical to JavaScript. If you are new to programming languages, a conditional is a line of code that checks if something is true. And then if it is true, we do something. So let's create our age variable again. Let's make let age equal to 45, or 46, let's say. Then we'll say if, and then in parentheses, age is greater than 45. We want to print out to the console, you are older than 45. Okay, just like that. So generally, with an if statement, there's also an else statement. So this basically means if this is true, do this. If this is not true, do this. That's why it's if else. So if the age is not greater than 45, we will say you are younger than 45. So let's change this value to 44 to see how this works. We can see we get you are younger than 45. There are also if-else statements, which lets us chain together conditional statements. Let's modify our age example. So right now we have if age is greater than 45. Let's also add in between these two an if-else, or else if I should say. Age is less than or equal to 45, and age is greater than or equal to 35. Then we want to print your age is between 35 and 45. And then we're going to change this down here to say you are younger than 35. So what this is saying is if your age is between 45 and 35, that's where this greater than or equals comes into play, or less than or equals comes into play, and this greater than or equals comes into play. So this, when you have an equals, that means 45 is included. So if this is set equal to 45, it will also trigger this. So we now have our age still set to 44, so let's try this. Now we'll get your age is between 35 and 45. So we can chain together as many if-else statements as we want, but it's considered bad style to have too many. Too many conditional statements bloats our code and makes it less readable. And writing readable code is arguably one of the most important parts of being a software engineer. If you have a number of different conditional statements that you need to chain together, then you are better off using what's called a switch statement. And this is what a switch statement looks like. So let's delete this. And we're going to create a new variable called switch test. And we're going to create a switch and give switch test as a parameter. And I'll talk about parameters later when we talk about functions. But basically all this means right now is that this switch is operating on switch test. So let's create a new, what's called a case, and then give it 1. Now this here is basically the same as saying if switch test is equal to 1. All right. So we have case is 1, and if it is, we're going to set value to 1. And then we're going to break. Then we'll have case 2. And if case 2 is true, we're going to write out value is 2 and break. And if neither of these things are true, we're going to have a default case. And that's going to print out value is not 1 or 2. And then we'll break. Now let's run that. So we see we get value is 1. If we were to switch this to 2, we would get value is 2. Now if we were to switch this to 3, we would get the default, which is value is not 1 or 2. The reason we want to break is to prevent something called fall through. Now, fall through won't matter in this scenario, but there are instances where your variable might match to multiple things in the switch statement. So to prevent that from happening and to make sure it only executes on the very first one, we write a break, and break is basically saying, break out of this switch statement. I don't need to be here anymore. So there's one more way that we can do conditionals in TypeScript, and that is called a ternary operator. Now, you might find this confusing at first, so if this doesn't make sense, don't worry too much about it at the moment. The ternary operator is basically just a question mark, and it denotes a conditional statement. So let's take our age variable. And what we're going to do is we're going to say if age is greater than 45, and this is where we use our ternary operator. We put a question mark. And then what we're going to do is say console.log, you are older than 45. And then over here, we're going to put a colon. And then on the other side of this, we're going to say you are 45 or younger. So what this is doing is we're giving it a statement. This is what would be in the parentheses in an if statement. Then this is saying, if it's true, do this part of this. Otherwise, do the part that's after the colon. So basically, this is just another concise way to write a conditional statement. So let's execute this and see what happens. So we see we're getting you are 45 and younger since we set age equal to 41. Now we're going to cover loops in TypeScript. If you're new to programming, a loop is just a piece of code that does something over and over. Loops are one of the most powerful parts of programming because it allows us to do repetitive tasks automatically, way faster than any human could do by hand. For example, let's say we have a list of 20,000 people, and they all have different paycheck amounts, and we want to add each of their paychecks up to get a yearly salary for each of the 20,000 people so that we can store it in a database. Doing this by hand would be a nightmare, and it would probably take weeks or even months. But with a loop and some programming, it can happen in a few seconds. There's a few different types of loops that are common to most programming languages. Let's start by looking at a for loop. So let's come here and we're going to create a loop for, and then we're going to set a variable inside this loop and call it I, and let I equal to 0. And then we're going to say, as long as I is less than 5, and then we're going to say I++. And then inside this, we're going to say the current loop value is I, and we're going to use string interpolation here. So what this is doing is we're creating a variable I, we're setting it to 0, and then we're saying as long as I is less than 5, do this, and after each run, increase I by 1. So let's run this and see what we get. So as you can see, we're going through this whole process 5 times until I is equal to 5, and then the loop breaks because our condition for the loop running is I is less than 5. You can also use for loops like this to walk through values in an array. So let's take this for loop and let's create an array called names and set the names. We're going to have Bob, Teddy, and Tina. Now, instead of saying I is less than 5, let's say I is less than names.length. This is telling us as long as we are still within the range of the array, keep going. And now we can say the current name is, and then we're going to access the array using I, like this. Now if we rerun this, you can see the current name is Bob, current name is Teddy, and so on. So this is just like how we were accessing our arrays earlier using the index, except now we're accessing every element of the array automatically with this one for loop. This way of accessing arrays by their index is known as direct addressing. For arrays like this, there are better ways to use for loops in TypeScript and JavaScript nowadays. So let's get rid of this for loop and let's write a new one. So instead of going by the index, we're going to say for const name of names. And then we're going to output, hello name. Just like that. And now let's run that. So instead of having to access each individual element using the index, TypeScript and JavaScript knows that we are taking each element in this array of names and naming that element name so that we can access them individually like this. And it's a lot cleaner and it's much more clearer what's happening based on the code. There's another way we can do a for loop in TypeScript, and that's called a for each loop. So this is a little bit different in the sense that we don't use a for loop like this, but we actually call names and then we do dot and then we do for each. And then we say name. And then what we want to do is console.log hello name. This is doing something similar to the last one, but there are some differences between for each loops and for loops that we're not going to get into in this video. Just know that this is another way you might see for loops out in the wild. So let's run it real quick and we'll see pretty much the same as our last one, just written a little bit differently. What this is doing is it's taking our names and then for each name, we're running this on it. So it's a little bit different than the standard for loop. TypeScript and JavaScript also has while loops and do while loops. A while loop takes in a condition and continues executing until that condition is met. Similar to a for loop, but a little simpler. So let's erase all this, and then let's create a new variable called value and set it equal to 5. Now, let's say while the value is less than or greater than 1, we want to execute this output. Value is value. And then we, at the end of the while loop, we want to say value is equal to value minus 2. Now let's run that and see what we get. You can see the first time it runs, we get 5. Then it minuses 2. The second time it runs, we get 3. But then the third time it tries to run, it's already broken this condition, so it exits the loop. So a do while loop is essentially the same thing, except the condition happens at the bottom instead of at the top. So we'll execute the loop at least once no matter what. So let's set value equal to 1, and then what we can do is do, and then we'll take this, while value is greater than 1. And as you can see, value is already equal to 1. So in a standard while loop, this would never execute at all. So let's run that. And you'll see we execute the first time no matter what. Next up, we're going to talk about how to write functions in TypeScript. Functions are pieces of code that are designed with reusability in mind, and they are the foundation of pretty much every programming language. In many cases, there are pieces of code that we're going to want to reuse many different times in different places. Functions allow us to write them once and reuse them everywhere. One of the core tenets of good programming is DRY, don't repeat yourself. So let's say we have a calculator app that we're building, and we have a division function, and we want to reuse that division operation in a bunch of different places in our app. Let's write that now. So there's a couple of different ways that we can write functions in TypeScript, but let's start with the most basic way. We're going to write a function and call it divide. And divide is going to take in two parameters, a and b. And those are both numbers. So we're going to want to use our type annotations here to let TypeScript know what these parameters should be. Otherwise, what will happen is if we don't set that, it's going to think that it's any type. And so any basically means we don't care what this type is. It can be anything we want. Now, there are some instances where you may want that to be the case, but most of the time that will lead to unexpected behavior. So definitely use your type annotations when you create functions like this. We also want a return type for the function. And so the return type for our function is going to be number. So what we want to do is we want to return a divided by b. Just like that. Pretty simple. All right, so let's use this. So now that we have this function, we can pretty much use it anywhere. So let's create a new variable called c, or cc, because I think we've used c already, and then set it equal to divide 10 and 5. And let's run this. Oops. And let's also print out the value. And now we see that CC is equal to 2. Now, since we have this divide function, we can use it pretty much anywhere we want. Let's say we want to divide 20 by 2. And let's do that same thing here. All right, we see that now dd is equal to 10. So the nice thing about functions is that we can use them anywhere. This might not seem like a big deal for this particular scenario, but sometimes we'll have really complicated operations happening in our functions, and not having to rewrite them in different contexts each time we want to use them saves us a ton of headaches in our day-to-day lives as software engineers. I'm not going to talk about every way we can declare JavaScript functions today, but I will talk about arrow functions, because this has become an increasingly common way to describe functions in TypeScript. Let's take our divide function and turn it into an arrow function. So instead of saying function here, we're going to say const divide. And then we're going to say divide equals, and then we're going to take our parameters and our type annotation, and then here we're going to put a little arrow, and that's why these are called arrow functions. And so now this is a function in the same way that it was a function before. So if we run our thing the same way we did in the past, we get the exact same answer. So there are some crucial behind the scenes differences that arrow functions have over other declaration methods, such as not being able to use the this keyword, but those differences are out of the scope of this video. Some people prefer the way arrow functions look over standard functions. One nice thing about arrow functions is that if you have a single line function, they have a feature called implicit returning, which means you don't have to specify a return type, it'll return automatically. Here's how you can write a function like this. So let's write a new function called add. And add is going to take a and b, which are both numbers, and it's going to return a number. And then, instead of adding parentheses like we did up above, we're just going to say a plus b. And now this is implicitly returning a plus b because we didn't include curly brackets and we didn't include the return keyword. So TypeScript knows that this is going to return a plus b. So this is a really simple and straightforward way to declare a function using a single line instead of a multi-line function. Before we finish up with our lesson for the day, you may have noticed in a few of the previous examples that I've used symbols such as greater than, less than. Programming languages have these symbols and they're called relational operators. And I wanted to make sure that I covered all of them so you know them when you see them. So there's the equals, which is a triple equal sign. And this is to say something equals something else. There's not equals, which is an exclamation point followed by two equal signs. And then, of course, there is greater than or equal to and greater than, and less than or equal to and less than. Now, there's also logical operators. And logical operators are used to combine and modify statements to make more complex statements. There are the two ampersands, which means and then there's the two vertical bars, which means or. And then there's also the exclamation point, which means not. And basically not just negates the truth value of the thing that you are performing. So let's look at an example. Let's have two variables m and n, and we're going to set m equal to 10 and n equal to 5. So if we have a conditional statement and we say if m is less than 11 and n is greater than 3, then we want to say both of these statements are true. Let's run that and see what we get. So since both of these criteria are met, we won't get this, or we will hit this code that both of these statements are true. Now, let's say m is not less than 11. Let's say m is 12. Then what should happen is that we never hit this console.log, which we don't. Now let's change this up a little bit. Let's say this is an or statement, and let's change our text to say one of these statements are true. Now, only one of these two things has to happen for this statement to be true. So since n is still greater than 3, when we run this, we will hit the code, even though m is not less than 11 anymore. Well, that's the end of today's video. I hope this served as a good introduction to TypeScript and its syntax. I didn't go into too much detail, but I just wanted to give a good overview of the language, just so you know it when you see it. So I'm planning to make at least one more of these videos to go into more detail about classes, exception handling, asynchronous operations, promises, async and await, and also common functions in TypeScript such as map, filter, and reduce. I'll also probably go into a little more detail about types and how to make more complicated types. If you feel so inclined, don't forget to subscribe and like the video, and I hope everybody has a great day.